Hey, welcome to video day 5. In this video, it's going to be a quick video on building series from known series. AP Calculus require that you know these four basic power series. You should be able to write the nth term and individual terms. You will often be given these series on the AP exam and asked to modify them. And they're expecting you to know them and not to have to sit there and take the derivatives to do it. They're giving you enough time to do it, considering that you know it and not to take the derivative. So please learn these four series, and you'll have a quiz on this on Friday. So how does this work? Well, if I know a known series, I know sine x, I should be able to transform sine 2x by using composition of functions. Pretty much is what we're going to use. So this is sine x, and if I wanted to sine 2x, every place I see x, because I'm composing, every place I see x in the original, I would replace it with 2x, because once again, I'm composing. So my power series for sine 2x, where I see x, would become 2x minus 2x cubed, 3 factorial, plus 2x to the 5th. Notice that I am putting parentheses around the entire thing, minus 2x to the 7th. Now, if it's multiple choice, it may not appear this way. It may appear more simplified. So it may look like 2x minus 2 cubed is 8. So that'll be 8x cubed over 3 factorial plus 2 to the 5th is 32. X to the 5th over 5 factorial. And 2 to the 7th, I think, is 128. It's 64 times 2, so 128. X to the 7th over 7 factorial. And yes, it may even be simplified more with the factorial. So then the question, what is the nth term? Well, we're going to do the exact same thing. Every place I see x in the nth term, I'm going to replace it with 2x. So this could be written as n to the 0 to infinity, negative 1 to the nth, 2n plus 1 factorial, and this x will be replaced with 2x to the 2n plus 1. And that's it. Not so bad, is it? All right, let's do that for sine x cubed. Once again, every place I see x, I'm going to replace it with x cubed. So that's going to give me x replaced with x cubed minus x cubed raised to the 3rd power over 3 factorial plus x cubed raised to the 5th power over 5 factorial minus x cubed raised to the 7th power over 7 factorial. And generally they will tell you write a 5th degree polynomial or write the first 3 terms of this polynomial. So generally you would be told that. So again, this can be written as x cubed minus x to the 3 times 3 is 9. Basic math failing me there. Plus x to the 15th over 5 factorial minus x to the 21st over 7 factorial. You may also be given the series and they ask you to find. So you may be given this and asked to find this. So it could go either way. All right, so what would my nth term look like? Once again, every place I see x, I'm going to replace it with x to the 3rd power. Everything else remains the same. And that is x to the 3rd raised to the 2n plus 1. Now, of course, if they simplify that, it could be written as 2n plus 1 factorial. All of this remains the same. and this would be x to the 6n plus 3, because we have to distribute that. When we raise a power to the power, we multiply. Okie dokie? Let's do an example with e to the x. E to the x is our favorite because it's so easy to write. So with e to the x, every place, now this is e to the 2x, so every place I see x, I'm going to replace it with 2x. So individual terms would give me 1, 2x, plus 2x quantity squared over 2 factorial, plus 2x quantity cubed over 3 factorial, which would simplify to 1 plus 2x plus 4x squared over 2 factorial plus 2 cubed is 8, 8x cubed over 3 factorial. One of the things that I want to caution you on, really, where most students make their mistake, is forgetting to put this in parentheses. It has to go into parentheses. You guys know I'm a stickler for parentheses. Okay? So then what would the nth term look like? Again, excuse me. Every place I see x, I'm going to replace it with 2x. So this would be okay? I'm so sorry. Now, for this one, I'm doing a product. So I would have to write out e to the x, and then every term is going to be multiplied by 7x. So I'm going to take e to the x and multiply it by 7x. So each term is multiplied by 7x. So that'll give me 7x plus 7x squared plus 7x times x squared would give me x to the third. And 7x times x cubed would give me 7x to the fourth. Okay. And again, how would I write that as an nth term? I would have 7x, x to the n over n factorial, which could be written as 7x to the n plus 1 over n factorial. Is that right? Because I'm multiplying everything by 7x, yeah, that would be correct. So when n is equal to 0, I would get just 7x, which is what I got here. When n is equal to 1, I'd get 7x squared. So that would work. Okie dokie? I'm going to let you do the rest of the notes. There is one more that I would like to do with you. And that, well, let's do e to the negative 2x. And then we'll do one more after that. Okay, so for e to the negative 2x, every place I see x, I'm going to replace it with negative 2. And I've written e to the x down here for you. So that'll give me 1 plus negative 2x plus negative 2x quantity squared plus negative 2x. The reason I want to do this is because I want to show you that when this becomes negative 2x, this creates an alternating series. So this would become 1 minus 2x. Now because I'm squaring this, this will now become positive. So this would be plus 4x squared over 2 factorial. And this, because I'm cubing it, becomes negative again. So this is negative 8x cubed over 3 factorial. So this has become an alternating series. So how would I write the nth term? Well, every place I see x, I'm going to replace it with negative 2x. So this becomes negative 2x to the nth power. And technically this is alternating because of the negative 2, but we sometimes would like to write it like this. because we just like to have that negative 1 to the n just to kind of show that it is alternating. But you could write it either way. Of course, we have our summation symbol. All right, I want to do one more with you, and that is 1 over 1 plus x. Now, notice the difference between this. This is 1 minus x, and this is 1 plus x. So I could write this as 1 over 1, excuse me, because I need it to look like this. So I could write this as 1 minus negative x. And that's the exact same thing as this. As this. This is the exact same thing as this, but now it's in this form. So now what I can do is every place I see x, I'm going to replace it with what? Negative x. That is correct. So this becomes negative x plus negative x quantity squared plus negative x quantity cubed. And you can see that this is going to produce, that should be plus from the original. You can see that this is going to produce an alternating series because negative 1 squared is positive now. And the next one, of course, would be plus x to the 4th. So this has produced an alternating series. So once again, when I write my nth term, I can write it as negative x to the nth power, or I could write it as negative 1 to the nth, x to the nth. And both are fine. And this is n equals 0 to infinity. Okay? Why don't you finish this worksheet for tonight, and then we'll go over these answers tomorrow in class. All right, I'll see you tomorrow.